So, homework-wise, what were the two elements?
Silicone and nickel.
Silicone and nickel. Okay, what's the atomic number of silicone? Yeah.
3s2.
Atomic number.
14.
14.
Yeah.
I'm highly confused right now. Well, I had my periodic table and my little thingamabob right in front of me. I know it's not. It's right there. Okay, let's focus. Hey guys, welcome. All right, so atomic number of silicone is?
14.
14. So I have 14 electrons to deal with. What's the next lowest noble gas? Someone from this section. Looks like you're falling asleep. Let's wake up. Next lowest noble gas is? The back of your test has a periodic table if you need to look at it. Next lowest atomic gas is? Neon. So I'm looking at the row before it at the very end. So neon is what atomic number?
10.
10. So I've used up 10 electrons, which means I have 4 left. Now I'm going to start on the row below neon, which is the third row. So I expect a 3 to begin the number. What's the first two columns? 3S.
S2.
So I have 4 electrons left. S can hold how many? 2. So 3s2. Now I have 2 electrons left. Where are they going to go? 3p2. So that is the correct answer for the first one. Questions?
I got it right. Wow.
Ryan, step out.
That's a good question.
Step out. Come back when you're ready. Okay, nickel. Atomic number?
28.
28. Next lowest noble gas is?
Argon.
Argon. Please do not throw things. Thank you. Argon. Atomic number?
28.
Come on, guys. Atomic number. Argon.
4s2.
18.
Oh, dear. Atomic number of argon. Everybody.
18.
18. That means I have 10 electrons left. Subtracting 18. Where are those 10 going to go? Well, I'm going to start on the left side in the, looks like, 4th row. So I get 4s2. Now, after that, I have, gently. After my 4s2, I get 3d. Why? Because that middle section there of your periodic table, the metals in the middle, are the D section, because there's 10 columns, right? And we go 1 row back because it's weird, okay? Now I'm going to count how many columns I have. 8. Is that how many electrons I needed? Well, I have 2 here and 8 there. That looks like 10. Okay? So, your ground state electron configuration for silicon is that, for nickel is this. Question? No questions. All right, we're going to move on. So, the next thing that we are going to do is we are going to go back to those addresses that we were talking about earlier. So, what are the 4 components of the address, if I may, of an electron? And the official term, so I'm not saying address, is quantum numbers. What's the first one? N.
Principal.
Next,
L.
L
Is it M or 2 or
and S. Okay? So, a lot of times they will ask you this question. For your last electron, so let's pick up that one right there, electron number 28. What are the 4 quantum numbers for it? Okay? A couple of things that you should know. First of all, N is simply the number in front. So, if I want that last electron, the 28th electron, N is simply going to be 3. L has to do with the letter. Now, we actually assign numbers to the letters. S is 0. P is 1, D is 2, F is 3. So what number do we have here? It's in the D orbital, so D is
2.
2.
Oh, what? Oh,
So
wait, oh.
it's in the third, like, main orbital, right? Then, as methyl quantum number is D, which corresponds to 2. Now we have to figure out M. Now this is where it gets a little funky, okay? For the D as methyl quantum number, what are the values of M?
8.
-2, -1, 0, 1, and 2. Remember that giant table we made, and then we were like, for the S, if you have 1 and you have S, you can have 0 here. Then we said if you have 1 or 2P, you can have -1, 0, and 1. Then for D, you can have -2, -1, 0, 1, 2. For F, you can have -3, -2, -1, 0, 1, 2, 3. Okay? So for the D orbital, our M numbers, or a magnetic quantum number, go from -2, -1, 0, 1, and 2. This is the way it fills the orbital. It starts at -2. So my first electron will go here. My next electron will go in -1. My next electron will go in 0, 1, 2. And then, because we have the spin, it'll fill those again, but with the negative spin electrons. So all of those, the first 5 were positive 1/2. The next 5 are, come on guys, negative 1/2. So if I have 8, I fill 5, 6, 7, 8. So that last electron will have a magnetic number of 0 and a spin of -1/2.
Hold on, wait.
I know, I'm gonna go over a few more. Don't worry. Just take a moment. That's great. As long as you're writing everything I'm saying, you're good. So, number in front, 3. As methyl quantum number, it's either 0, 1, 2, or 3, depending on the letter. Here, this one is D. Okay? Now, we said in the D orbital, you can fill 5 spots, right? Those 5 spots correspond to magnetic numbers of -2, -1, 0, 1, and 2. So, for each one, starting with the first one that goes into the D orbital, we fill the positive spin here. I'm going to draw like a little up arrow. The second one will fill this guy. Third one will fill this guy. Fourth one will fill this guy. Fifth one will fill this guy. Then we go all the way back. The sixth one, we fill this guy, but it's with the negative spin. 7, 8. So I see that my last electron right there filled the 0 magnetic quantum number with -1/2. Drawing the picture. Okay? So we'll do more examples, and hopefully through these more examples, you will see it. So let's deal with the last electron in silicon. What are the quantum numbers for the last electron in silicon? Well, I have to look at the same things again. I'm going to look at N, I'm going to look at L, I'm going to look at M, I'm going to look at MS. Okay? The last electron that I put in silicon was this 2p2. So, what is N? N is 2. Why? Because I got it right there.
Wait, isn't it 3P2?
That is a 3. Thank you.
So,
Yeah.
is it only like the last part?
The last, because I'm asking about the last electron. Each one of these electrons has an address.
Okay.
But I'm specifically asking for the last one right now. Okay, so this last one, the second one that went into the p orbital, first of all, N comes from the 3 because it's in the third principal quantum number. Okay. The next thing we get is L. If this was S, L would be 0. If this is P, which it is, L would be 1. Why? Because it says so right here. You write that?
Yeah, you got it.
Okay. Now, magnetic numbers. What are the possibilities for magnetic quantum numbers in the p orbital? That's correct. So for S, we just have 0. For P, we have -1, 0, and 1. For D, we have -2, -1, 0, 1, 2. And for F, we have -3, -2, -1, 0, 1, 2, 3. So for the p orbital, my options are -1, 0, and 1. Okay, which one is that going to fill? Well, if I have 3 spots, I'm going to fill the first spot first. That would be the -1 spot. Then I'm going to fill the 0 spot. I have no more electrons. So we're talking about this one right here. So it fills the 0 spot. What's the spin? Well, we fill the positive spin first. So +1/2. Yeah,
Is that a 1 or is that
it's an
just
arrow pointing upward.
like a half it? Like a,
Okay, let's try another one. What's the ground state electron configuration for calcium? Go.
Oh, we're gonna.
Yeah,
write this
go
out.
for it.
for calcium.
Here's your periodic table. Calcium's on the left side. The back of your test has a periodic table. You should be able to do that quickly. Again, I don't want the full thing. I want you to start at the next lowest noble gas. So you're writing out the whole list and going to do this two things. So start here. So start at R. And then add this. Did you do it?
Yeah. No, it's on this one. Yeah, I'll take it pretty well.
Got it? Okay, so the ground state electron configuration is the thing that we were doing before. We like write out all this stuff. Where's calcium?
Why does it have two? Because
It's right there. So you're gonna start at R.
why does it split up 2 spaces? Because it's P2?
Why does what fill 2 spaces?
Like, you know how I did the arrows? Why is always filled 2 spaces?
Because it's P2.
Okay.
If it was P3, it would fill all 3. Yeah.
Oh, okay, that makes sense. And
Yeah.
I always do we always do the positive one first. Okay.
Question?
I'm confused, like, what am I supposed to do with it?
Where's the next lowest noble gas?
So look at the row before it.
Rows, wait,
Rows are sideways, columns hold up buildings.
Look at calcium with his.
Okay, so calcium is element number 20. So find calcium right here. Front row. I'm walking you through it right now.
Oh.
Calcium is here, is in the 4th row. So I'm going to go to the 3rd row at the very end. We get argon. Then we have, argon is 18, so we have 2 electrons left. So now we're in the 4th row. Always start with the s orbital because these are the s. And I have 2 electrons left. So this is argon with 4s2. Okay? If I want to find the location of the last electron added, that would be number 20. I could do that by finding N, L, M, and MS. What is N? For the last electron I added. 4. What is S?
0.
S corresponds with 0.
Oh, I see how you do it.
Okay? The options for M when I'm in the s orbital is 0. There's only one option, it is 0. So if it's the first electron, we fill the positive spin. If it's the second electron, we fill the negative spin. So the address of that last electron, or the quantum numbers, are 4, 0, 0, negative
God
1
bless
half.
you.
God bless you. Yes.
What's the M again?
M is the magnetic quantum number.
Is there?
So depending on if you're in S, P, D, or F, you have a lot or a few.
For spin?
Wait, let me finish her question first, and
They were
then, yeah.
done.
Does that make sense? So when we have S here, my options for M are 0. There's only one option.
Oh,
So that's how I knew it was 0. Over here, we were in the p orbital, so I have -1, 0, and 1. I have 3 spaces where electrons can live. When I was in the d orbital over here, I had 5 spaces, because d has -2, -1, 0, 1, or 2. Within each of those, I could either have a positive spinning or negative spinning electron.
so what determines the up down, like?
You always fill the up first, and then you fill down.
So how do we know how much downs we're gonna put?
So for this one, there were no downs because we only had 2 electrons. So we tried to fill up first, and then we stopped.
Wait.
Here, we have 1 spot, and we have 2 electrons. So the first one was up, the second one is down. So we know that this one was going down. Good questions. Yes,
Why for spin is it negative 1 half instead of?
because it's the down one.
But wouldn't you?
Because we ended on negative.
Oh, so if you end on a negative, if you end on it going down, it's gonna be negative
Mhm.
1 half. Oh.
Yep.
okay.
So you fill the positive first and then the negative. Yeah.
Got it.
I think I'm just confused on how to find M.
So-
it's just what's in the middle.
Yeah, you kind of have to draw that picture. So you want to draw this picture, and then that will show you where you're at.
Here goes best
So for this one, is it like the picture that's driving you crazy?
Yeah, because they're always pointing towards the middle. Like that. Can M equal negative?
So the last one has been in the middle for every example. That's all. So it could be -1, like if we ended here. So what element would that be? That would be cobalt,
How do you know this boy?
huh? Because it's 1 less than nickel. So if you look at your periodic table, that element with 27 electrons is cobalt, and so it ends on that one. So its last electron lives at 3, 2, -1, -1 half.
I think I'm still confused.
So whatever last one we ended on is the one that you're describing. So when we had 8 electrons left and 5 spots, we fill the top ones first. So that's 1, 2, 3, 4, 5, 6, 7, 8. So that's why it landed on that one.
Oh.
Yeah.
Okay.
So for cobalt, it has 27 electrons, so that's argon, 4s2, 3d7. So it has 1 less, so that would be this one.
Okay, so
Because it lands, the last one is that one.
okay.
Okay, so now we've learned a couple of things. We've learned how to make this, which is called the ground state, electron configuration. We've learned how to define the quantum number of the last electron we placed. Now, I've already been doing it, but we are going to learn the abbreviated orbital notation. Ooh.
Is it like the decimal number at the bottom?
No, it's these pictures I've been drawing this whole
Oh,
time.
boring.
So, abbreviated orbital notation is you basically drawing out the picture of your electrons and where they're going to live. So, the trick is that for every s orbital, that's all. So for every s orbital, you're going to leave one spot. There's one spot for electrons to live. How many electrons can live there? 2. You can have one pointing up and one pointing down. For p orbitals, you get 3 spots. Why? Because there's 6 electrons. So you'll fill your upward facing ones first, then you'll fill your downward facing electrons. And what I'm doing, just to blow it up, is like that kind of shape, almost like a 7, and then that kind of shape. So this would be your positively spinning one, and this would be your negatively spinning one. Yes?
Would this be wrong what I put down here?
Exactly what I put here is what you should put. If it's not, then it's wrong. Okay, so that's P. For D, how many spots would we expect? We already did it.
5.
5. Why? Because 5 times 2 is? Oh dear. 5 times 2 is? 10, right? And 10 electrons fit in the d orbital. So if I'm filling the d orbital, sorry, I fill the positive ones first, then I fill the negatives. Is it okay if I stop there? If I only have 9 electrons, I would stop right there and not fill the 10th one. Right? If you have a full d orbital, then you would fill it. And then F is 7 of them. I'm not going to write it. So if I ask you for the abbreviated orbital notation for silicon, we know that the ground state electron configuration was neon plus 3s2, 3p2. I would write that as the following. Neon, an s orbital gets 1 spot, then I'm going to leave a little bit of room. P orbital gets 3 spots. The s orbital is completely full. The p orbital only has 2 filled. So that's your abbreviated orbital notation for silicon. You do everything after the noble gas. Ooh. I love the sound effects in this class. It's good. The snoring from the back row, the like, the constant commentary from this area of the room. What? Oh, Micah. No, just kidding. Yes.
What does determine the arrows again?
So we always point upward, and then you're really looking at how many electrons fit. So in this one, I have 2 electrons, so to fit in this one spot. So one goes up, one goes down. For this, I have 6 possible spots, 3 pointing up, 3 pointing down, like this. But I only have 2 electrons to fit in there, so I have 1, 2. We'll do more examples, and hopefully it'll illuminate. Yes?
So also, I mean, I kind of already did it, but see for P, for example, it would be -1, 0, +1 on the denominator.
Yeah,
part.
but you don't write that.
You don't write that. It's applied or implied.
Yeah. Please remove your candy cane from, thank you. Okay. Yes. During this riveting lesson, he has to go to the bathroom. Oh dear. Oh dear. All right. Yes, you may. Let's do aluminum. We've already done the ground state electron configuration for aluminum. How many electrons does it have? 13. That's right. Thank you, one person. Let's try that again. How many electrons? 13. What's the next lowest noble gas? Neon is correct. Then aluminum is in the 3rd row. So I have 3s2, 3p1. 1, because it's in the first column. Remember, columns hold up buildings. The first column of the P section of your periodic table. No?
Because columns.
Columns?
Because
Because columns go up and down. If your building was built on columns that were like
I'm not gonna build
this way, like your building died. Like here's your roof,
Oh,
like
roof
you just got
building.
crushed. You're like down there. You're like, ah.
Wait.
Oh,
what?
my building
That makes
fell on
sense.
me.
What did you just build? You just built an eye with an
It's like
arrow.
saying something.
All right. So how am I going to write the abbreviated orbital notation of this? Simply writing neon. S orbital has 1 spot. P orbital has 3 spots. S orbital is full. There's 2 electrons. One going up, one going down. P orbital, not full. How many electrons does it have in it?
1.
1 going up. So that's the abbreviated orbital notation for aluminum. Let's try something ugly. How about iron? Let's write the ground state electron configuration. How many electrons does iron have?
Iron.
Yes.
Iron.
Question?
Yeah, so if you don't put anything in the box, do we have to like explain out?
Yeah, because you have 3 spots there. So that's saying that it's a p orbital. Yeah. It's more for like you to visually see it. Like nobody's going to ask like, hey, where's the... Like I'll ask as a teacher, but nobody in like chemistry would ever ask you that. But you would need it to be able to figure out the quantum numbers. Yeah.
So would it be like incorrect if we put like a comma in between?
If
the-
you don't do it the way I've done it, it's incorrect.
It's just confusing.
Don't you hate it when teachers do that?
No. It's,
I hate it when they're like, my way or the highway, and then,
Highway. I don't know. It's fine.
I'm sorry.
I'm joking.
Okay, moving on. So, iron. Atomic number is
26.
26. We've got some work ahead of us. What's the next lowest noble gas?
Argon.
Argon. Thank you. Okay, after argon, what row is it in?
It is in
4th row. So, argon has 18. That means that I have 8 left. So I'm going to do 4s2. That uses up 2 of them. Now I have 6 left. 3d6. Okay, how do I write the abbreviated orbital notation? Well, I have an s orbital that just gets 1, and it fills both of them. A d orbital should fill 5 spots. So I'm going to leave a little bit of room, but everyone can be happy.
Thank you.
You're welcome. I did it just for you and everyone else in class.
Huh?
'Cause they've all paid for a ticket to this exciting event. Okay, I have 6 electrons. How am I going to fill them? 1, 2, 3, 4, 5, 6. You will see, if you look this up online for iron, you will see all sorts of different things because iron is not happy about that last electron.
what a shame.
Very much not happy. So, yeah, iron does not like the fact that it's barely unbalanced. So, it does weird things. But this is, based on what I've taught you, the correct answer if we put argon here.
Why is there that many spaces?
Because it's a d orbital, so you get 5.
I thought it was.
Every d orbital has 5.
Oh, right. And then
Yep.
back to 7.
Mm-hmm. So, I filled 5 spaces. The 6th one went on the negative.
Confusing myself.
All right. And that is that. So, I'm done. I would like you guys to redo number 6 and then number 7 for homework. So now you can do all of number 6. We pretty much did it for homework anyways. And then I want you to do number 7. And that is it.